So what's this? What do you think? Okay, it's a learning curve. And in fact, it's a steep learning curve. And as soon as you start to hear about RxJava, that's the first thing anyone's going to say. RxJava has an extremely steep learning curve. And it's true. But if you're over here just getting started, why concern yourself so much with getting to like this superstar level of RxJava when instead you could just take a few baby steps and incrementally get better over time? And that's what I hope that we can do today. I've spent a lot of time learning more and more about RxJava and what it does behind the scenes. And I would love to help you to be able to do exactly the same. So welcome to RxJava in baby steps. Today I'm going to cover what we call the 3 O's: observables, observers, and operators. Then we're also going to talk about some of the most popular operators that you're going to come across when you're working with RxJava. So those are things like map, flatMap, and filter. And then finally, throughout the course of the whole talk, I'm hoping that you can better understand what we call marble diagrams, which are used to express the intention of the various operators. So what is RxJava all about in the first place? It's all about programming with asynchronous data streams. And when we hear that phrase, asynchronous data streams, what do we mean? Well, here are some examples. It could be something like click events, reading a file, push notifications, keyboard input, device service updates. Any of these things can be thought of as happening asynchronously, meaning at any given time and somewhat outside of your normal program execution. So let's just look at an example of the sensor updates. So we can say like GPS. If you're tracking a person's GPS locations, that can change over time and you will get different values. So they may start off at one spot and you'll get a certain set of coordinates. As they go to a new spot, you get another coordinate. And then perhaps with a delay, they're in a whole nother location and another value comes in. So this is something we would consider an asynchronous data stream. Let's look at another example. This time with a server response. Now this is different from what we saw with GPS in that it's a one-time deal. So a request can be made to the server, a response comes in. It's just one thing, one item in the stream of time, but it's still a valid asynchronous data stream. Let's look at another example. Same thing, server response happens, but this time no value comes back. This is also valid. The response is an error, but this is still a valid data stream. So let's test your knowledge of what you've learned so far. Which of the following is an asynchronous data stream? Would you say A, click events, B, database access, C, a server response, or D, all of the above? Right? It's D. In fact, almost anything can pretty much be thought of as an asynchronous data stream. And that's really what RxJava is all about. But you may be wondering, hey, I handle these things already. So I already know how to handle click events. I already know how to look for GPS updates. What's the big deal about RxJava? Why should I use it? Well, here's the most important thing that I'm actually going to say today, and that's this. You don't have to. You don't have to use RxJava. But hopefully, throughout the course of the talk, you'll stay and you'll find out some reasons why you may want to use it. Okay, so I'm going to share with you different reasons, and we'll walk through various examples of how RxJava can help you out in your development. But first, I want to let you in on some scientific research that I conducted. I'm an Android developer, so I took to Twitter, asked a bunch of other Android developers, hey, why do you use RxJava? And the responses literally just came pouring in, and there were things like predictability of functional programming, making multiple API calls in parallel, visualizing asynchronous operations, and more and more and more. So I took all of the responses that came in, and then I grouped them into these categories. So these are like some of the main things that people love about RxJava. We have chaining and abstraction, data transformation, threading, composability, avoiding callbacks, and doing things in a non-blocking manner. Now, how is it that just one library can do all of these different things? Well, let's take a look at some short examples to help you to understand. So first, data transformation. This is some RxJava code. Don't obsess over it yet. By the end, you'll know exactly what this code does. The key point here is this map. This is one of the operators, and this is how RxJava can take one set of inputs and give it another output. So if we took this RxJava code, it will give us a bunch of old school winky emojis, okay, as a string. So that's just using map data transformation. What about chaining? That's one thing people really love about RxJava. We took the same code, except this time we chained in the filter operator. This is going to impact the output that we receive. So now we only get one row of old school emojis. So just like that, we see data transformation, chaining using RxJava. Another thing people really love about RxJava is that it adds another level of abstraction to your code base. So it's focusing on the what you want done versus the how. So if we took that example code that we just saw in the previous slides, behind the scenes, it's just Java code. Really, it's written in somewhat of an imperative style that we're really used to, but it's hiding all of this from us so that we don't have to worry about it. We just know we want to have an impact on our output. So we use these commands, and RxJava is hiding all of this for us. And so that brings us to our next question. RxJava is A, the silver bullet, B, simply magic, C, pure voodoo, or D, a library? Sometimes it feels like it, but it's just a library, right? It's something that you've learned to tame in the past. We've all worked with various libraries that seemed super complicated initially, but over time, you can definitely learn to use RxJava. It's also not a silver bullet. It's a tool that comes with great responsibility. So when you start working with RxJava, you will have pain points and you will see areas where the library kind of falls down on you. So if you're familiar with Kotlin even a little bit, you might be thinking, hey, Kotlin collections can do a lot of these same things. Kotlin has map in order to change items. It also has filter to selectively choose what gets outputted. So why would I bother using RxJava when I can just do the same thing with Kotlin standard library functions? But let's look at how they work behind the scenes. So first, if we start out with our list of numbers, 5, 6, and 7, the map operation is going to be called on every single one, and then it's going to create this like intermediate list of objects for us. The same thing is going to happen when filter gets called, intermediate collection of lists for us. So the key takeaway is that when you're using the Kotlin standard function, it's doing extra work behind the scenes. It's creating these lists, and it's also taking place in a blocking manner. Whereas when it comes to RxJava observables, for the most part, they're lazy. So they're not going through this extra effort of creating these additional objects, taking up memory inside of our applications. And you can also tell them, hey, I want you to do this work on a background thread. So I don't want you to do this in a way that's going to block my UI. But someone may say, well, Kotlin sequences exist for that reason. They do things in a lazy way. But let's look at how this works. So you're starting out with that same list, 5, 6, and 7, and now you're just going to view it as a sequence. So what happens is it'll go through one item at a time, perform the whole pipeline. So it'll do map, and then it'll do filter. But notice there's no intermediate collection this time, which is really nice. That's what we wanted. And then it will do the same thing for 6 and the same thing for 7. But this brings us to the question once again, well, why RxJava? Kotlin sequences seem to solve this problem completely. Well, remember what we said about RxJava. The whole point is programming with asynchronous data streams. So if we took this same problem and we moved it into an RxJava world, it may look something like this. There is no list, right? There may be nothing there yet. All you're saying is, this is what I want you to do. When a number comes in, this is how I want you to handle it. So when 5 does show up, then it will go through the entire pipeline. And the same thing for 6, and the same thing for 7. So this is one reason why people really like working with RxJava, is that you can handle the data as it comes along. So another perk is that it has a very flexible threading model. And basically, this allows users to choose, hey, I want to do this operation, but just not on this thread. I want you to do it on this background thread or another computation thread. And this happens by means of what RxJava calls schedulers. So there are a ton of different schedulers available that you can use, but basically they're the boss. They say, instead of doing your work here, do it over there. Okay, so let's look at a quick example. This is our same map code that we saw before, and now we're just adding one new operator into the chain, subscribe on. We specify scheduler, schedulers.io, but it can be a huge list of schedulers that are available to you. The main thing is RxJava is hiding threading behind a very nice abstraction layer so that you don't personally have to worry about it. Another thing that's really cool about RxJava that's not readily available in standard collections is all of these additional operators. So they have operators that can affect the interval something happens, the time that it happens. It can also combine observables in a really complex, interesting way that just isn't available when you're working with standard collections. So now that we've started to understand why people really like working with RxJava, you need to know some basics in order to be productive with it. And so those things are the observable, the observer, and then the operators, also known as the 3 O's. So today we're going to talk about all 3 of these in fairly high detail so that you can get a good sense of what it is that RxJava is bringing to the table. So let's start first with the observable. So the observable can be thought of as producing a stream of events. And this can take place in either a hot or a cold manner. So let's look at what we mean by that. So if we say an observable is hot, that means that once it's created, it gets busy doing its work. So it gets created, it decides, hey, this is what I'm all about. I'm all about giving hugs, and then the hugs just come. It doesn't wait for anyone to get the hug. It just says, hey, that's what I'm doing, and it gets busy. So this is a hot observable. What's an example of that? Maybe it's something like click events could be a hot observable because a person could just be clicking away inside of your application, whether or not you're listening to their events or not. But if we contrast this with something that we'll call a code observable, it's waiting for someone to say, I'm interested in your work. So the observable gets created, and then it just waits. It's just waiting peacefully. And then once a subscriber shows up, it says, oh, someone cares about my hugs, and then they just start giving them out. So that's the difference between hot versus cold. And what could be an example of this? Maybe this has something to do with reading a file. Perhaps you wouldn't want to get a file, download it, read all of its contents if no one cares about that at all. That would be a waste of resources. So that could be a pretty good example of a code observable. But now the question remains, where do I even get observables from? Well, observables are available through factory methods. So here's an example of the observable class. This is an operator, create. It's letting you know I'm responsible for integers. And as I mentioned earlier, this code is all in Kotlin, but if you're familiar with Java, you should be able to follow along. And then it takes in a subscriber as one of the parameters to a function, and it's going to be responsible for calling all the different methods on the subscriber. And we're going to talk more about subscribers, or what we call observers, shortly. Another way you can get an observable is through a different factory method or operator called just. And in this case, I'm saying, hey, I'll let you deal with how the subscriber methods are called. All I know is I want to just get these 3 things, item 1, item 2, and item 3. And then a final example is by means of the interval operator. In this example, we're saying, hey, I care about numbers, and I care about those numbers every 2 seconds, so just give me a new one. So this is how various ways that we can get, This is various ways that we can get access to an observable. So here I'm using the create method that we talked about before, and I'm passing in the subscriber as the reference, and I'm saying, hey, I care about integers. So I'm going to throw in some logs because I want to be able to see what time this happens, what thread is this taking place, and what step am I in the process. In fact, I'm only interested in 3 numbers, the numbers 5, 6, and 7. And that's by means of these back-to-back calls to the onNext method. This is how my observable is going to let the subscriber know, here's the information you requested from me. And then finally, we have a call to the subscribers on complete. So this is me saying, I'm done. I don't have any more data for you. You can move on. And so we'll definitely be getting more into that. Now, if we run this code, notice what happens here. We're only just getting the done, right? We didn't get all of those other logs that we had printed before. Now, why is that? It's because of what we talked about before with hot versus cold observables. So this is a cold observable. It's not going to do any work because no one said they were interested in it. So just to prove that I'm not lying, I went ahead and I added a subscriber to this particular observable, and then, ta-da, I get all of the data that I'm interested in. So I see all of those statements printing out inside of my logs. So now it's time for another question. Observables can A, emit items, B, be cold, C, be hot, or D, all of the above. Right, I want you to feel smart, so the answers are all D so far, okay? Right, work with me. This is how you can better understand RxJava and what's going on behind the scenes. So yes, observables can do all of these various things, which is why they're a key aspect of how RxJava functions. So let's move on to talk about the observer. The observer is the abstraction used in RxJava for listening to, or as the name implies, observing the various events that the observable puts out. So in its most complex form, it's this interface of observer, which takes in a type T, and it has these various methods that it's exposing for the observable to call. So if we start out with error, on error, this takes in a throwable. So this is why some people will say RxJava treats errors as a first-class citizen. So it has its own method in order to handle when something happens outside of the normal execution. There's also on complete, which we looked at before. This is how we notify, hey, we're done here. On next, which takes in a type T of T. This is the main thing that you care about. So if you're all about processing users, T is your user. If you're all about processing apples, T is your apple. So this is your main method here. And then finally, there's an onSubscribe method that takes in a disposable. And this is how you can say, actually, I don't want to listen to events anymore. I'm no longer interested. So if we were to look at the life cycle of an observer, it would go like this. So first a call is made to the onSubscribe method once it's hooked up with its observable. Then throughout the course of its normal flow, its onNext method could be called 0, 1, or many times. It all just depends. And then if it completes successfully, a call is made to onComplete. Otherwise, a call is made to onError. So this is the whole life cycle of it. Now, if we look at an example implementation of that interface, it would be something like this, where we're overriding all of the different methods, and then we're just logging what we receive back from our observable. So if we connect this to the observable via the subscribe method, so that's what you see down there with the arrow pointing through. Let's look at what happens. So we get all of those different logs. It goes through and calls every single method on the observable. But sometimes observers don't care about all of that extra information. And for that reason, RxJava has something called a consumer. It's just like a baby observer. And in this case, it has the one method, except, which takes in the type T. And you can think of this as kind of like the onNext from what we saw previously. So in this case, we're just going to log it. And in fact, I use that same message next to show that these two things are strongly related. So if we run this connected to our observable, we're still getting the same output. We're still seeing those numbers, 5, 6, and 7, just like before, except we don't have to worry about the extra methods that we didn't care about. But if you look really closely at this code inside of an IDE, you'll see like a gray squiggly line going on. And this is because in Kotlin, this code is extremely verbose and definitely not necessary. It's letting us know we can convert it to a lambda. So if we go through, we convert it to a lambda, it now looks like this. But we're not using this variable anywhere, so we can just go ahead and smash it into our subscribe method. But then again, the IDEs are going to complain. It's like, hey, why are you giving me this extra information? I already know, so you can just drop it. All right, looking a little bit better. But now you have a lambda as the last parameter inside of a method, so you can just drop the parentheses. That's totally valid Kotlin code right there. But if you take it a step Further, we can completely get rid of the T in the declaration with the arrow, and now we're just down to it. Because Kotlin knows, okay, this lambda has one parameter, and this is how it looks. So when you see code with RxJava in Kotlin, you're gonna see a lot more of this. And indeed, if we plug it into our same observable, we get exactly the same results. So this is what you can expect to see when you're looking at RxJava code in Kotlin. But now it's that time again for a pop quiz. Observers A have a life cycle, B, they always complete, C, they never error, or D, all of the above. Right, it's A, good. I didn't want it to be D forever, so yes, it's A, right? They have a life cycle and you have to respect those methods. And if you're gonna go through the effort of using the create variation of the observable, then you need to make sure you're respecting that life cycle. So awesome. We're now on to the last of the 3 O's, and that's the operator. So you can think of operators as helping you to transform, combine, and create observables. So let's look at an example of that. Here we're going to take our friend, the map operator. We've seen it a few times before, but let's look at how it really works. So it knows how to take a function that goes from one type of something to another type. That's all map knows how to do. So let's say we're really positive today and we want to take frowns and we want to turn them into smiles. That's all our map is going to do. So every time a frown shows up on the source observable, it's going to dump a smiley face in its place. And it's going to happen the whole entire time throughout the life of that observable. So this is what map does. Now recall, we've seen an example of map before, and I said, don't worry, we're going to go over it. Now we're going over it. So this knows how to take the numbers 5, 6, and 7, and it maps them to a string full of winky emojis, right? And it gave us this whole output. So if you're not super familiar with lambdas, you may see this and go, I have no idea, how was I supposed to know that was gonna give me these like winky emojis? But let's look at what's really happening. So if we expand that map method out and we look at it in its full form using Kotlin syntax, you're gonna get something like this. So it starts out by creating an anonymous class of type function that knows how to work with integers and strings. It only has one method that it needs to implement, that's apply. The apply method says, if you give me an integer, I'm gonna do something to it so that in the end, you end up with a string. What is the something that I'm gonna do to it? I'm going to take this winky string, and then I'm gonna repeat it the same number of times that correspond to the integer that you gave me. And that's it. So just to see them kind of together, these two are doing the exact same thing. So one, super verbose, but really helps you to see what the transform function is all about. And then the latter is extremely concise Kotlin code. So anytime you're working with RxJava, just go ahead, expand it out if you find a particular operator really confusing. It definitely helps me sometimes when I see what the transform function is, and then I can better wrap my head around, okay, this is what I'm trying to do. I'm trying to go from here to there. So before we look at our last operator, I'm going to give you 2 questions to test your knowledge. What would be the output of this RxJava code? Okay, so we have observable.just with the numbers 1, 2, and 3. We have a map operator that doubles those numbers, and then we subscribe to it and print it out. So think about that for a second. Is it A, B, C, or D? Okay, right, it's C. Okay, now let's look at how we got here. We took 1 and we doubled it to get 2. 2 and we doubled it to get 4. 3 and we doubled it to get 6, okay? And there's no sort of fancy things happening where some things are happening in parallel or it's on another thread. It's just some blocking RxJava code. So we got C. Now, this time, we're going to add a filter in there where we're going to reject any numbers that are not less than 6. So would it be A, B, C, or D? Yeah, right? This time it will be B. Why? Because if we just go this way, 2 doubled is 4. Yes, that's less than 6. But 3 doubled is 6, and 6 is not less than 6. So that's how we end up with B. So if you just kind of take your time when you're learning RxJava, start off with simple things like this. Numbers tend to work a little bit better when you want to understand how the chaining works and how the operators work, and then you can really start to wrap your head around it. So let's look at one final operator that you're going to come across a lot, and that's flatMap. So this is the flatMap marble diagram, and it gives us some insight into how the operator functions and what it's supposed to be responsible for. Now, at first glance, it does look really similar to map, but it differs in a few key ways. So if we look closely, the first thing to notice about the flatMap transform function is that it goes from an item to an observable of potentially another item. And that is really important, because then it's going to flatten those emissions out into one single line. So let's look at it in action. Okay, so here's our code. We're going to just give 2 frownies, and we're going to flat map it to a down arrow, because frowning is bad, and so we want to convey that in our code. Now, we're going to start out with 2 observables, the original and the one that's going to hold our final result. Okay? So as soon as the source gets busy, it's going to give us a frown. And look at what flatMap does. It creates an observable of that arrow. It subscribes to it and then prints it out as just a single arrow. Now another frowny face comes in. It does the same thing again. It's creating an observable, subscribing to it, and then flattening out as a single arrow. The cool thing is that our subscriber shows up. The subscriber only sees those final arrows. Now, why would something like this be extremely powerful in programming? Well, it's because it helps us to do long-running asynchronous operations without necessarily having to block the main thread. So let's take an example. Let's say you have an observable of users. But what you really want is an observable of all of the blog posts that these users have ever written. You can use flatMap to go through every single user, get all of their blog posts on a separate thread, and then have them all collected back to you, so that your subscriber should just go through and work with only the blog posts. They don't have to be concerned with the users, and they don't have to wait. Everything can just happen asynchronously. So flatMap is an extremely powerful operator, and when you start looking at RxJava code, you can potentially see flatmaps all over the place. And there are other operators just like it inside of RxJava that you'll get to explore the more you look into the library. So some people might be thinking, okay, that's great, Annyce, this is wonderful, but what about flowables and maybes and back pressure? And literally the list can go on and on and on when it comes to RxJava. The key thing to take away is that this is RxJava in baby steps, and I want to leave something for V2 of this talk. But seriously, the question, should you use RxJava? This is a list of questions that I've compiled. So first, do you even like functional programming? Do you need to process items asynchronously? Do you have to compose data in some complex, intricate ways? Do you have to handle errors gracefully? If you can say yes to all, if not most, if not all of those questions, then my answer to you is yeah, it depends, right? Because you may have some valid use case for RxJava in your application, but the added complexity may be more than what you and your team are willing to take on for that particular project. On the flip side, tons of companies are using RxJava or some form of reactive extensions, and it's multi-platform, so you can be using it in Swift, you can be using it in JavaScript, et cetera, et cetera. So it really depends on what you're trying to do with your career, as well as your current job description, team, company. So today we focused on the basics. We looked at the observable, the observer, and the operators. Hopefully you feel like you're making some steps in the right direction when it comes to learning RxJava and how it works under the hood. Thank you so much for attending. That's all I have. This is my website where I've listed various resources for learning more about RxJava, as well as a link to these slides. Also, this is my Twitter handle @BrownGirlDev. Feel free to follow me for tech tips and witty banter. Yes, so this is more on the resources that I have available, and you'll find links to all of these things on the webpage. So thank you very much. That's it.